And hello again, everybody. And hi, Bruce. We meet again this week with another of the Spotlight series. This week, we are going to discuss front running and secret auctions or bids. This is a very hot topic for the blockchain industry, as everyone knows. Everyone in the DeFi space, if you've ever interacted with dexes like Uniswap, you know those terrible bots that front run you. You set up a buy order, and then they jump straight ahead you. They get a better price, then they immediately sell afterwards. But in any case, I'd like to pass it over to you, Bruce, to explain to our community what MEV is, what secret auctions are, and why NPC technology helps prevent this dramatic outcome of basically stealing from our pockets.
Yeah. So I first heard about this. When I first heard about this situation, I was like, oh, wow, this is um, an interesting issue that comes up because generally people want transparency, right? And that's the reason why blockchain was created to provide complete transparency and make sure that everybody is able to see everything. But as a result of that, different types of issues came up, right? So in the traditional front-running space, or the front-running issue is well known in the traditional, trading platforms. So when you're trading stocks or any other kind of like an auction system, if you are able to gain information that is non-public, right? This is which is private, that's going to take advantage of the rest of the people that don't have that information. It puts you as an advantage, and you're able to take it, take advantage of other people as a result of this information. So you have things like insider trading, or you have other front running type situations, which is now illegal, right? It is illegal um, in many countries. And that's a result of a particular piece of information that is said to be private. But now we have this system where everything is transparent. But because of that transparency, the same problem occurs, right? So when I first heard about this problem, I was like, wow, this is really interesting. You really do need a balance of privacy and transparency in order for trust to be built, right? And this is a really good example of it. So now I'm really excited to go over this problem with you.
Yeah. The thing is that, and this brings new paradigms into discussion, into play, because front running is illegal in traditional markets, right? It's insider trading. It's people feeding information in non-official manners, and yeah, people getting ahead of the trades. But being blockchain's public ledgers and being the mempool, and I won't get it too much ahead of the topic, but it is not technically illegal, right? It's just if people are playing by the playbook, by the rules. It's just that
Mm-hmm.
some people got smart and they created bots, and it is a nuisance. And regular Joe and Jane doesn't have the technical abilities to prevent that. So, I mean, even last week there was this case where this validator actually a validator attacked a bot, and I wouldn't say it stole 20 million. It just counterattacked a MEV bot. I'm not sure if you saw this article, which also comes into play. How trustworthy are validators using public knowledge? Because again, it is not illegal. It's just a validator attacking a bot who is attacking regular traders. So it's all such a big gray area of nuances that, I mean, as soon as we have privacy, this just goes completely outside the window.
Yeah, that's a great point. You mentioned the fact that it is not illegal by its current definition, because the current definition is really talking about information that was private, right? Information that wasn't available to the public. The main principle of front running being ethically uh, questionable clearly is there with the MEV attacks. Clearly, ethically, it is questionable. But legally, because the legal definition of insider trading or front running is defined using the context of the traditional market system, it doesn't apply. So it doesn't become illegal, even though you could see in the spirit of what front running was supposed to, the legality of front running was supposed to prevent is still prevalent in the MEV attacks in the crypto space, right? So yeah, it shows you that we still probably have a little while to go before we can be considered mature, right? So it's definitely an interesting situation, and it's exciting to see the space evolve. Um, but with that said, maybe we should jump into how Partisia Blockchain, by balancing the privacy and transparency, is able to help solve these kinds of issues.
Absolutely, and we were kind of focusing on MEV or front running, but this also ties in with surveys and secret surveys and the numerous use cases that society has for having layers of having a private medium to which people can actually interact in a safer, more controlled environment without the shenanigans associated with auctions.
Yeah. This is one solution out of many that we're going to showcase with MPC technology. So let me see if I can begin sharing my screen. So we're going to talk a little bit about privatized bidding and how that really enables you to be able to eliminate front running, and how MPC privatizes the bidding process. And as a result, we're really bringing integrity back to the overall auction or the overall bidding process. And so we talked a little bit about front running. And its definition, again, is in the traditional sense, is the legal practice of placing a trade or some sort of an order based on advanced non-public knowledge of an expected large order or an expected change in the company, or whatever it is that will actually impact the stock price, whether it's going to go up or whether it's going to go down. And based on this non-public knowledge, somebody will be able to place an order, whether it's a sell order or a buy order, to take advantage of that knowledge that they gained. So an example of that is here, let's say that there's a broker, right? Then this broker has a client who is wealthy. And this wealthy client orders a large stock purchase through the broker. Now, the broker has this non-public knowledge, right? He knows that this client gave him an order to place a large purchase. Then what the broker can do is he can actually place an order for himself ahead of the client's order to get at that price, whether it's a sell order or it's a buy order, whatever it is, right? Because the stock prices will get not manipulated, I'm sorry, because the stock prices will be impacted by the client's large order. So the broker places his own order ahead in front of the client's order. Then the broker executes the client's order, raising or perhaps lowering the stock price. And then once that's done, the broker will then execute another order to profit through the changes of the stock price that occurred as a result of his client's order. So that's a really great example of this illegal practice of placing a order ahead of some other event, a non-public knowledge event, to profit off of that information. So when we take a look at it from a blockchain perspective, everything is public, right? So like you mentioned, by its definition, it's not illegal. You can't catch somebody because the blockchain is transparent. You can see every single trade that's out there. And here we have an example of a front running working on a DEX, and this could be a AMM or it could be a different type of a DEX. It may have an order book. as it's defined, it might not have an order book, but the concept is basically the same. An attacker, looks for a particular opportunity, right? It has a particular situation leading to an opportunity to insert himself into the we'll call it an order book or a set of transactions events that is on a mempool. And after looking at the mempool and the orders that are being planned to be executed, he finds a particular situation where he can slip in his order with a larger gas amount to make sure that he actually gets ahead or in front of that particular situation to take advantage of other people's orders that's in the order book, right? And this happens because of how how nodes work in an EVM system, right, or in other blockchain systems where you can actually prioritize yourself in a mempool by putting a higher gas amount, and then the node operators will prefer that because that has a higher gas amount, and they'll execute that order ahead of other orders that are out there. So this is how, at a very high level, how front running would work on a DEX. And again, this is how it gets executed from step by step. As I explained before, the bid with the higher gas goes ahead of the other bids, ensuring that this attacker can purchase at a lower price than others in this particular example. And then after the final order is executed from the pool, then he can reinsert himself and then either sell or buy at a different price than he originally had his order placed in the beginning, right?
So basically, to add on to that, so what the attacker is looking for is a good size order. So basically, a good liquidity pool, a mini liquidity pool within the mempool. So he buys it, then the legitimate buyer buys after him, and he immediately sells into that liquidity, into that one transaction, guaranteeing that he buys and sells and pockets the difference. Is that correct?
Yeah, exactly. Right. And I think they call it like a sandwich attack, right? We call it a sandwich attack. Yeah, exactly. And again, and to your point, it's not illegal. It's by its definition, it is not non-public knowledge. So while ethically questionable, it is not illegal. And this is all being done through a bot. The other point that you mentioned earlier is that it's the people who have technical knowledge that are very savvy who are able to take advantage of this. So in this situation, it's not that they have non-public knowledge. They have expertise in a field that most people would not have, and and through that, they're taking advantage of other people in this particular situation. So because this is all being done on a bot, it's impossible for anybody to, who's doing this manually to actually see that this is happening and try to prevent it, by themselves. Like they can't pull back an order because this is all happening in milliseconds. Right? So that's the problem with auctions or bids in a blockchain. But what if you were able to hide both the amount and the price or any other factors in the auction, right? If you're able to hide what's in the actual auction itself or in the bids themselves, then whether it's a bot or it's a person, they would have an extremely hard time figuring out, hey, what's going on inside the mempool? What's going on inside there? I can't see I can see what's in there, but the details around the bids are hidden from me. So I don't know what situation is happening, and I'm not able to put in any kind of an order to try to front run anyone. Right. And that's the interesting part about how now you're able to take privacy into a transparent system to be able to provide a protection against things that are unethical, that actually gets introduced because of the transparency of the system, right? So you can see in the situation, sometimes full transparency doesn't work. Full transparency sometimes causes situations
Mhm.
for other people to be able to take advantage of you, or so on and so forth, right? So this is a great example, I think, of the balance that is needed between privacy and transparency.
And correct me if I'm wrong. This same principle obviously applies to bids, to auctions.
Yeah, absolutely. Um, we'll go into some of the other examples of how we as an organization has actually helped um, provide that privacy in auctions, not just in the front run resistant DEX, but in other auction examples that we've actually provided solutions for. So we'll review that at the end as well.
Okay.
But you're absolutely correct. Yeah. So we talked a little bit about how privatizing the bid amount will help prevent an attacker from taking advantage of the situation, right? But you have to be able to also compute on those hidden values to say, hey, the auction was completed and we know who the winner was. And that's what MPC does, right? It is not just about hiding the values. It is not just about proving something that is zero knowledge, but being able to compute on those values. And so in this situation, yes, we have a auction that's running through a privatized order details. So we have a sell order, we have a buy order, the information is private. But you need to be able to compute on those hidden values as well. And ultimately, in the end, show the world, hey, this was the final outcome of the bid, right? And so through multi-party computation, we both are able to hide the actual um, the bid values and then publicly announce through multi-party computation what the final order record was, right? And so we talked a little bit about the different solutions that we provided before. And I think this is a great segue into some of the interesting facts about Partisia. Right. So Partisia was actually, as we spoke before, Partisia was actually founded in 2008, and we have world-renowned cryptographers in our organization working on Partisia. And it's really interesting to see that even like when you go into Wikipedia, as an example, and you go into multi-party computation, secure multi-party computation, um, our use cases that I'm showing here is actually recorded in Wikipedia. So as an example, let me show you the secure multi-party computation Wikipedia page, and you'll see the history of it, right? And you'll see people like Ivan Damgard, who's one of our founders, listed as one of the key contributors in multi-party computation. Scroll down a little bit here, you'll see the first large-scale and practical applications of multi-party computation was the execution of an electronic double auction, the very similar auction situations that we're discussing here in the Danish sugar beet industry, which took place in January 2008. This was us. This was Partisia, right? And so, so when we talk about the different use cases that we have implemented in the past, so Danasco was the example there. We provided multiple different types of solutions, whether it's in a private setting or in a blockchain setting. And these are the partners that we've been working with, from government bodies, OTC platforms like Tora, to large industry players like Danasco. Partisia and the Partisia Blockchain Foundation has helped bring integrity, really bringing integrity back to the bidding process.
This you reminded me of my early eBay days, where bidding was it was open, it was fun, it was exciting until this concept of sniping started happening. And it took me a while to realize why I was losing all my auctions, because people would wait until the final second and they would just throw all the guns into the auction. And obviously, you had to be there refreshing every 30 seconds, every second on the final 30 seconds of the auction, and just hope and cross your fingers and hope to win. So I mean, I would very much welcome MPC technology in platforms such as eBay to avoid the stresses of auctions. But in any case, coming back to the more institutional side, how can institutions out there that might be interested in adopting or testing the use case for MPC actually get in touch with us to have a conversation, to have a sit down, so that we can advise them on best practices?
Yeah, we've actually had a lot of interest from different organizations in the trading or the financial industry. So we've had Forex companies that are coming in. eTrusty on this list is working on public tenders to ensure that public tenders auctions are being done in a non-corrupt way. So the best way to contact us is through, check out check out our site, www.partisiablockchain.com. Certainly email me or email us with any questions, any interests in working together with us. Also on the description below, we'll add additional links in how to contact us, as well as our development page, where you can get more insight into the technology behind it to see if people would like to research a little bit more. So.
And to finalize, a little blast from the past in the industry, the very first project tackling auctions on chain, if I'm not mistaken, was a project called Open Bazaar. It was a great endeavor. They worked really hard. I remember being part of the testing team at the time as a community member. And the problem was well, first of all, it was built on Bitcoin, which is not ideal because 10 minutes for average block time for settlement is not ideal. And then obviously all the troubles regarding the publicly viewable data that everyone was just cross-referencing to get better deals and to, in a sense, front-run the auction process. So I'm very excited, and I hope that builders out there start thinking about potential dApps to disrupt yet another industry which hasn't been disrupted yet, because this very key element, this ingredient that is really necessary to make auctions shine on chain is finally available. So I'm very excited to see what comes out of this.
Yeah, that's awesome. Yeah, I would love to see that as well.
Okay, I think this essentially ends this presentation. Any final words, Bruce, to our community?
Yeah, I think next week we're going to be talking about private settlements, which is related to this. But now we're going to be talking about how do you privatize once the settlement is complete, right? So an auction is a type of a settlement. But next week we'll talk about how do you privatize the actual result now of the settlement. So that should be a pretty interesting conversation.
It will, for sure. All right. Thank you very much, everyone, for tuning in, and stay tuned for next week's presentation. Thank you very much, and see you next week.
Thanks, guys.